Factoring a trinomial square. So your answers are going to look like this, like x minus 3 squared or 2x plus 5 squared. Well, if you remember, what it means to square something is really just to multiply it by itself. So x minus 3 comes from x minus 3 times x minus 3. I'm going to go backwards first to kind of show you the pattern, and then I'm going to show you how that pattern is going to be used to factor that. So if I were to multiply this, I get x times x is x squared, x times negative 3 is negative 3x, negative 3 times x, negative 3x, and negative 3 times negative 3 is positive 9. So I get x squared minus 6x plus 9 by combining like terms. So there's a couple things that I want you to notice that we're going to get into. Both the first and last term are square terms. So this is an x squared, and this is a 3 squared. It's kind of like the work we did with the difference of two squares. Now, how could we use those two answers to get this middle term? Well, if I take my x and my 3, I'd have to multiply it by a 2 to get it to be a 6x, and there happens to be a negative. Let's see if the same thing happens with the other one. So 2x plus 5 comes from 2x plus 5 times 2x plus 5. And I'm going to factor that, I'm going to multiply it. So 2x times 2x is 4x squared. 2x times 5 is 10x. 5 times 2x is 10x. And 5 times 5 is 25. Combining like terms, I get a 4x squared, a 20x in the middle, plus 25. Well, I'm noticing again that my first and last term are still square terms. This is a 2x being squared, and this is a 5 being squared. So can I use those numbers to get my middle term? So if I put my 2x and my 5 multiplied together, 2 times 5 is only 10. I would need another 2, just like I did on the last one. Well, why do we need a 2? Well, before you multiplied, that 2x times 5 was 10x. Well, if you look on the second line, where I had my green, there are two 10s. That's where the 2 comes from. On the previous one, I had x times 3 before I multiplied it by 2 because I had two 3x's on the green term. So I'm going to show you how this works going the other direction. So I'm just showing you kind of like where things come from. So as a little reminder on your factoring flowchart, we always start off with our GCF. So first double check to see if there is something that they can all be divided by. Once you've done that, we're getting to the question of, is the coefficient of x squared a 1? We've done our diamond problems, but now we're getting into where it is no. So you can actually have trinomial squares where the coefficient of x squared is a 1, but those can also be done as diamond problems. For the purpose of today, we are just going to be focusing on a trinomial square. So if you look at what we have written here, the first and last term are squared terms. So you're trying to figure out what is that a and b essentially that was multiplied. What are those two things that were being squared? And if you'll notice in my pattern, I have a 2 in the middle. So the a and the b go into the middle, whatever it is that you're multiplying, and there's a 2. Now there are two possible answers on this because it depends on if the middle term is being added or subtracted. That middle term tells you in your answer if it's a positive or a plus or a minus binomial. So let's actually try this one. Let's practice this. Well, this could be done as a diamond problem. I'm not going to do it as a diamond problem. I want to show you it as a trinomial square. So I noticed that the first and last term are square terms. Again, very much like the work of a difference of two squares. So this is an x being squared, and this is a 7 being squared. Now I'm going to take those two terms, I'm going to put them in the middle, along with that 2. This 2 is what is always included there. Now, why are we doing that? We're making sure that this middle term checks. So this right here is your work. And then you need to do your check for your middle term. Check the middle term, because there might be some where it doesn't actually match. So is 2 times x times 7 14x? Yes, it is. Check. It matches. So since the middle term does work, we're going to take the x and the 7 that were our square terms. It is a plus because there's only pluses in this problem, and it is squared. So the factored answer is x plus 7 squared. If I'd done this as a diamond problem, what multiplies to 49 and adds to 14? 7 and 7. We'd have 2 of them, x plus 7 squared. Now this one cannot be done as a diamond problem because this doesn't start off with an x squared. But this first term and last term, again, are a square term. The first term is a 2x and the last term is a 3. So this is my work. Now I need to do my check. If I put those two numbers, the 2x and the 3, in the middle with a 2, do I get a 12x? Does the middle term work? 2 times 2 is 4, times 3 is 12. Check, it works. So I'm going to take my two answers, I'm going to put them in a binomial, and I'm going to square them. And again, I know it's a plus because that right there is a plus. That's why it's a plus between the 2x and the 3. Okay, let's try another one. 25x squared minus 10x plus 1. So my first and last terms are square terms. 25x squared is 5x being squared, and 1 is 1 being squared. So let's bring them into the middle along with a 2 and see if, I'm supposed to multiply them, to see if my middle term checks. 2 times 5 times x times 1 is 10x. Check. Now for my answer on this one, it's actually going to be a 5x minus 1 squared because of this minus right there. That minus makes it a minus binomial that is being squared. Okay, last problem. First term and last term are square terms. 9x squared is 3x being squared, and 4 is 2 being squared. So let's bring them into the middle. 3x times 2 along with another 2, and check our middle term. Is 2 times 3 times 6. 2 times 3 is 6, times 2 is 12, not 8. This one does not match. So this one would be not factorable. There might be another way to factor this, but that is something we haven't done yet. So that is not factorable. So that is why you have to check the middle term, because not all the time, the middle term doesn't always work. Okay.